Thank you for
Oh,
coming along to this webinar from Anastasia Korycinska from the Defra in the UK. Anastasia, thank you so much for this. And now, there you go, take it away.
thank you. So this is a recent example of modelling climatic suitability for a pest in the United Kingdom. Had to do it under quite a lot of time pressure. It was an interesting example because I needed to come up with answers quite quickly, but the data on the pest were very incomplete. So in the UK, we have horizon scanning is a sort of routine part of the work we're doing. And Pochazia shantungensis, this hemipteran bug, it first came to attention in our regional plant protection organisations alert list. It is an Asian pest, probably native to China, and it had recently been reported in the Aleppo region in Turkey and France in 2019. So we had it on our list of things that we needed to be worried about and have a look at. So it's a brown-winged plank hopper. As I said, it's probably native to China and it's become invasive in a few extra areas. And it has recently made a large geographical jump and got into parts of Europe, especially around the Mediterranean. It's extremely polyphagous. The adults and nymphs feed on both herbaceous and deciduous woody plants. There's a suggestion that the nymphs prefer to feed on herbaceous plants if they're washed off the trees. They just stay on the herbaceous plants and feed. But the adults, when they're mature enough to lay eggs, they show a sudden host switch and a very definite preference to leave the herbaceous plants and go back to the woody plants. And this is because the adults lay eggs in typically 1-year-old stems of the woody plants. They literally saw their way into the twigs with the ovipositor. The damage is really quite significant. They can get halfway into the twig. And if you think about the disruption to nutrient flow and so on, that's what really causes the damage rather than the sap feeding. Despite the damage, it's not known to be a vector. Potentially, it could be a sort of dirty syringe for viruses, but that's not been recorded, and there's no specific host pest virus association known. So, as I said, this PRA had to be done under quite a lot of time pressure. It was a bit hard to come up with a linear presentation for this because I was grabbing information everywhere I could all at once and doing quite a lot of strands of analysis concurrently. So some of this I had thought that I might be able to do some form of species distribution modelling. So I was collecting distribution records as accurately as I can. The crosses are where I've had latitude, longitude, or some sort of exact locations, and the circles are where I've just had to go on a place name. So it's thought to be native to sort of Zhejiang in China, around about the Shanghai area. It's invasive in South Korea. I've actually reduced the number of South Korean records I could have put on the map. And they're also thought invasive in Japan. It's been found, as I've said, in Europe, usually around the Mediterranean, but we've also got that record in Sochi over to the east of the map. Question marks. So the one in France, there were some nymphs found in a glass house, and it's been found in flower markets and things in other parts of Europe, but we don't know it's established. We don't know that it's got a perpetuating breeding population there. So in the UK, we have a rapid screening through the Plant Health Risk Register. We do this because there's an awful lot of pests out there, and the rapid screening enables us to have a sort of precautionary ranking of pests. We'd hope to spend 1 to 3 days on the research. It is precautionary. If we don't know the answer, we tend to assume the worst because it's always when you're doing a rapid screening, that's the approach you have to take. Otherwise, you run the risk of dismissing a pest that's a real risk and just doing nothing further on it. We present the evidence internally. It's about 4 to 10 pages, and the external website, which anyone can see, has extremely summarized data. In contrast, our pest risk analyses are detailed documents. I can't think of one recently that's been less than about 50 pages. If we don't know the answer, you research, and you research until you either know it or you have a good hope that you're somewhere in the area. And crucially, we conduct the pest risk analyses to international standards, ISPM. And that means that while both sets of the rapid screening and a pest risk analysis goes through at least 3 and quite often more cycles of internal review before we publish anything, when we've finished with the risk register, it's only the highly summarized scores that we show, because we're having to take making a lot of assumptions. It's not done to international standards for a risk register entry. However, for a pest risk analysis, the full draft PRA is made available on the website. Stakeholders can comment, and we'll incorporate those comments into the final version. And the very final step in the process is, because we've done a whole load of work on the pest risk analysis, obviously the PRA overwrites the risk register scores. We've done an awful lot more research into the organism. And so once we've completed a PRA and it's been finally signed off, the last step in the process is to overwrite the risk register scores. So in our first screening of Pochazia, it came up quite high on our risk register, and this was in March 2023. As I say, when we don't know the answer in the rapid screening, we have to be precautionary and assume the worst. We did know that we were being quite precautionary, but we don't have any other option. If you've only got a few days to research a pest, then that's what the process is designed to do. So the scores on the risk register were high enough that suggested we should be attempting to keep the pest out of the UK. It could potentially have impacts on us. And there are legal criteria to be defined as a quarantine pest for Great Britain. And the risk register rapid screening suggested that it could potentially meet those criteria. And so the decision was made in a policy meeting that we should be taking statutory action. If this pest was found, we should be taking action to destroy the consignments if it was an import, or eradicate the population if it was found breeding. However, it's not sound to have continued statutory action only based on rapid screening. And so as part of this, there was a request for the detailed analysis in a PRA. However, we're a relatively small team in the UK, an awful lot of risk analysis to do, and so we added it to a prioritised waiting list. We then started finding Pochazia in our imports in 2024, and this led to an awful lot of plants being destroyed at the UK border. Said the PRA waiting list was prioritised. We reviewed that, and instantly this became one of the top priority PRAs we had to do as soon as possible. It wasn't just theoretical anymore. We were actually causing impacts on businesses by destroying these plants. It was actually made a little bit worse because the lorries from Italy, they were usually importing vast mixed consignments of plants, but there was no separation between the different plant species. Adults and nymphs are very mobile, so we had no evidence the plant they were found on. We didn't know if that was the plant they originated on or if they'd moved onto that plant during transport. And so when we had adults or nymphs, unfortunately, the whole lorry load had to be destroyed. When later in the year, late autumn and over winter, we only found eggs, we were then able to, because the eggs aren't mobile, destroy only the infested plants. But if we had a mobile life stage of the pest, we were causing real life impacts. We might wish plant health to hit the newspaper headlines, but probably not this sort of headline. Unfortunately, there aren't identification characters. We couldn't even get our labs couldn't even get the nymphs to family reliably on keys, and it had to be molecular analysis. By the time the sample's been taken, sent to the lab, the molecular analysis has been done, validated, and it's all gone back. We were holding lorries for quite a while, and if we weren't destroying the plants because of the presence of pests, sometimes the plants weren't too healthy by the time we were able to let them go. So all this was just adding to the pressure on trying to do the PRA. So that's some of the background. And I already knew when I was trying to set up the PRA, it was coming into the country, it was coming in on planting material, it was highly polyphagous, so it was likely that it could either stay put on the materials coming in on, or it wouldn't really have a problem finding other suitable hosts in the UK. The key thing to address in the PRA was therefore going to be the establishment. Could it form a perpetuating self-sustaining population in the UK? If it can establish, will it be able to build up to damaging populations? And one of the impacts in South Korea was that the adults seemed to be laying eggs around the time the fruit orchards were starting to ripen. So if you think about your fruit, just, the final push, the plant's putting all these nutrients into the fruit just as it's ripening, and an insect really disrupts the sap flow in the twig by sawing through it to lay its eggs. That's where the timing of that seemed to be one of the causes for high impacts in South Korea. So was that going to be a factor in the UK? And finally, if it could establish and be damaging, what should we do about it? Is there anything practical we can do about it? So the last 3 points on this slide are what I had to concentrate on in the PRA. So there has been previous work done, mostly in South Korea, where it's been an invasive pest since about 2010, plus or minus a few years, depending which source you read. There was some models done by Kim et al. In 2015. So over on the left, there's the distribution maps, and over on the right are their probability distribution. Match the data quite nice, all very well. However, if you compare the predictions to the actual distribution in 2022, it looks a little bit less rosy. There was another load of work done by some slightly different South Korean authors, but again, I felt they had the same issues, that modeling a pest based on presence absence of distribution when it's still spreading, it's not ideal, and I didn't think it was worth trying to extrapolate these models into Europe to come up with a prediction. I thought it was just too uncertain. So that meant I was then thinking about the inherent biological characters of the pest. I couldn't find enough information to be able to run a full climax model, but there were quite a lot of thermal data, temperature available, at least for the eggs. We're going to look at these diagrams in bits later. But just to give you an idea, this is the sort of level of data various authors I could find on eggs. Nymphs aren't looking too bad in terms of data points, but if you actually dig in, it's really only one paper. By the time you get to adults, we just have one data point for the flight threshold. So it was, even for temperature data, this was looking a bit interesting. And if you have a look at the bottom half of this diagram, we've actually got at least 5 different lower threshold temperatures for development, for when nymphs would start to hatch from the eggs. So some of this work was trying to work out which of these I should be using for the PRA. One thing to say is that there's the lowest threshold of all 4.75 degrees. Just even looking at this diagram, I wasn't too convinced that one was accurate, because even if you go sort of about 7 degrees up in temperature, you're seeing extremely low rates of hatch. I think that 0.13 percent hatch. It was about 1 egg out of 800 nymphs managed, a nymph managed to emerge. I would expect if the threshold really was below about 5 degrees Celsius, by 10 degrees you should be seeing a bit more hatching than that. As I said, the nymphs were all based on one paper. First, second, third and fifth, I could live with that variation, but the fourth instar threshold is very different, and I would like to see some further validation before I was sure what was going on there. So looking at the top half of this diagram, now one important thing to say is that I've taken data points from multiple different authors using multiple different protocols. So for example, there's a sort of 78, 18% hatch, all very close to each other. That's probably because it's different authors in the PRA. There's a supplementary table where each of these data points is given a reference. But all in all, if you look at days to hatch, you can see below about 15, 18, there's quite long time periods. It seems to be struggling. If you're sort of up between about 20 and 30, you've got usually quite high percentage hatch rates and usually quite short development periods, which is suggesting to me it's happier at quite warm temperatures. Looking at the different thresholds again, we've got this tool we've been developing with the UK Met Office, and it just helps you really quickly visualize different thresholds and accumulated degree days. It's just a way of, I don't know whether 10 degrees and 400 degree days is approximately the same as 12 and 200. So it's just a way of visualizing, and you can see there that the two lower thresholds are showing different predictions to the two warmer thresholds. So it's just a way of suggesting, yes, we have a problem. We need to be working on this a little bit more to work out which of these thresholds are actually accurate. So to choose thresholds, there's an awful lot of information in this graph. The crosses are our theoretical lab predictions of thresholds and accumulated degree days, which we've discussed in previous slides. So it's just a different way of showing these. The coloured blobs are from where I have found phenology papers. So 2 different sites in China in 2005, for example, saying that in this site, nymphs were first observed, they hatched on this day. And you've got the similar South Korea and Turkey. So they're from different years. You've got 2019, 2020 from Turkey, about 2011, 2012 South Korea, and 2005 in China. So from the actual phenology dates, I then looked at historical daily Met data from Weather Underground. It's worth pointing out these aren't official Met data sources, and I don't have any way of establishing just how accurate each Met station is. But I basically took a Met station close to each of the phenology papers for the same year. So the Turkish data will be from 2019 or 2020. The South Korean data will be from 2011 or 2012. And I calculated on that Met station the date the nymphs emerged at that given threshold temperature, how many degree days were actually accumulated. So then I was able to make a comparison between the theoretical and the actual accumulations. And it's starting to look as if the ones sort of 11.6, 12.1 are probably the best matches to reality. I did put less weight on the Chinese records. Their actual Met station data were always substantially lower than the other sites. And I wondered if perhaps the eggs had managed to accumulate more development before the winter. And so come spring, they needed fewer degree days before the nymphs could hatch from the eggs. It's worth noting that the degree days are calculated using a daily minimum and maximum temperatures, assuming a sine wave over the day. So even where the mean temperature is below the threshold, it's still possible to accumulate some degree days. I was mentioning the phenology, so this is just another way of visualizing my different data points. These are from different years. The data are collected to different levels of accuracy. You can see in China and Turkey, we've got 2 different generations a year. There's 2 hatching, 2 flight periods of adults, 2 periods of oviposition. In South Korea, there only actually seems to be 1 generation. One author does note that they found some early instar nymphs late in autumn, and they wondered if that was a partial 2nd generation that wasn't able to complete, that the summer laid eggs had actually hatched, but not been able to develop. And the European records, because it's quite newly invasive, we don't seem to have very many data points. It's worth noting some of these Italian points are actually from interceptions in the UK rather than published literature. So looking at 12 degrees or so, and I'll show you why in the next slide. In the UK, we'd expect the overwintering eggs to be hatching quite late in the year in comparison with the current range. And it's actually our eggs might be hatching about the same time the 2nd generation of eggs is hatching in China. This is the first hint that the UK is probably going to be quite cool for what this insect needs. So going back to the Met Office web tool, there's a facility to download geotiffs and set your own thresholds. The colours on this slide are after a Korean paper model. So I was just trying to see how the UK might compare with South Korean stuff. In South Korea, most eggs are predicted to be hatching in the sort of orange-red times, so sort of London perhaps is equivalent to South Korea. And this is the warmest spring in an over 30-year time series. If we go into a middle spring, a sort of middle of the not particularly warm, not particularly cool, the eggs are going to be hatching in summer substantially later than most parts of South Korea. Whether we'll ever see a spring as cool as 1991 again is debatable, but in the cooler springs, our eggs are going to be hatching really quite late on in the summer. And given the nymphs need quite a long period of heat to develop, and adults need quite a long period of their pre-oviposition period of at least a month, it's starting to look a bit dubious whether it could complete its life cycle. Just as a summary, I've been throwing numbers at you, and this was my summary in the PRA of how I thought temperatures that might be of importance to its life cycle. Below about 15 degrees, it doesn't seem that development is really going to be possible. There might be some, but it's very slow. The insect's going to be under really significant thermal stress. 18, 20 degrees, it's starting to get into the range that then it seems that the growth and development's likely to be successful. 23 degrees is adult flight threshold, but this is nighttime temperatures. In the UK, our nights are very seldom over 23 degrees, even in London. If you were sitting next to me when I found that paper, you might have heard a muttering, "Oh, the adults will be doing an awful lot of walking here then." And as you get up to the high 20s, low 30s, that seems to be the optimal temperature for Pochazia's development. Mystery did some global maps of degree days, and looking at the ones over 18, that's where the insect's starting to develop really quite well. I've used the distribution points again here, circles and crosses of where it's known to be found. And everywhere where the pest has been recorded, so both in Asia and Europe, the two maps at the bottom left are close-ups of sort of southern France, northern Italy, and around Turkey and Sochi. So the coolest point I could find where the pest has been recorded still achieves over about 150 degree days. The very warmest part of the UK under Mysteries map, Mysteries analysis, was only about 7. It's worth noting the degree day calculations differed here in that it was just the daily mean temperature minus the threshold temperature. In the UK, we have quite a few days where the daily maximum's above 18, but the daily mean is below. So using the Baker method I've referred to earlier in this presentation with the sine wave, we would accumulate some degree days. But if you're using the daily average, this map and these calculations won't give the UK any credit. So this is, I suspect it may accumulate more in the UK than the map would indicate, but there's still a very substantial gap. Looking, and this was the graph that basically sealed the case. After all this analysis, working out what was appropriate, these degree days are actually calculated from multiple data points, multiple data readings per day. So it's one of the most accurate methods of calculating degree days. We've got the current range in Asia, sort of reds and pinks. Remember, it's only got 1 generation a year in South Korea, 2 generations in China and Japan. The sort of bluish range are the invasive parts of Europe. And the grayscale dotted lines sitting at the bottom of these graphs are the temperatures we expect in the warmest parts of the UK. So I've taken Cornwall in the southwest, London in the sort of southeast with the urban heat island effect, and Kent in the southeast, which is insofar as the UK ever has a continental climate, Kent tends to have that. It tends to have the sort of hotter summers, colder winters. So there's a really substantial gap. I don't know exactly what the insect needs in terms of accumulated degree days over 12 degrees, but there's such a big gap between anywhere it's present and where the UK is. It doesn't look as if it's going to be capable of establishing outdoors in the UK. So going back to the UK process, presented that draft PRA in March 2025, and we published that. We got a number of stakeholder comments, some of which could be answered just using data in the PRA, but there was one really interesting response concerning the risk to polytunnel production. Literature suggests that polytunnels are warmer in the day, especially when the sun's shining, but they drop close to ambient outdoor temperatures at night. However, the literature was based on Southern Europe and New York State in the United States, and so actually corresponded with the stakeholder who made the comments and who had a really helpful response. They managed to talk to different owners of different polytunnels, and we got temperature data from different sites in the UK. There's temperature log data over 3 years, so we could actually do our own modelling with real UK data. It was an interesting one to communicate because we had a PRA published that said no statutory actions appropriate, and we were still taking action at the borders. Again, this goes down to being precautionary. While we were still investigating the full risk, we had to be precautionary. But again, this just meant working under quite some time pressure. So most of the polytunnels had at least 30-minute or 20-minute different hourly logs. The data could be quite partial over the year. In the UK, it's common for polytunnels. The plastic comes off in autumn once the crop's been harvested, and it only goes back on in late winter or spring when the new crop's ready to be put in. But we still had really great data, and it was we had one site in particular where we had both outdoor and indoor loggers very close to each other. Indoor meaning inside the polytunnel. Just as an interesting aside, I've been mentioning the Baker sine wave degree day calculations. They're a really good approximation for outdoor temperatures. I think our outdoor data log, the two taking multiple hourly readings, or the min-max and equations, they only differed by about 20 accumulated degree days over the whole year. It's insignificant. But inside the polytunnel, perhaps because the polytunnel's much warmer, but the minimum temperature is much the same overnight, the Baker method really overestimated the degree day accumulations, and that's just a nerdy aside. So here are some actual logs, and you can see here we back up the literature. The red outdoors, they're about the same minimum temperature overnight, but the daytime temperatures can be a lot higher. In summer, the sides of the polytunnel tend to be rolled up and doors opened. Growers are we want it to be warmer, but we don't want it to be so hot that it affects the crop growth. So in spring, the difference between polytunnel and outdoor temperatures may be even greater. So this is much the same graph as I presented earlier. I've just simplified it a bit. So the current range are the thin blue lines. I've taken some out just to make the graph simpler. We've got the dotted grayscale for outdoor in the UK, and now the polytunnels are the sort of reds and purples. You can see here that the data are a little bit partial, not always across the whole year, but in most years, yes, the polytunnels accumulate more degree days, but in general, we've still got quite a substantial gap between that and anything Pochazia sees in its current range. However, in the 2022, and it was an extremely hot summer in the UK. Some outdoor temperatures recorded were over 40 degrees, which for us is pretty unusual. And there's one polytunnel that's starting to accumulate quite a lot of degree days. So it's an element of uncertainty. But overall, trying to think about the establishment in polytunnels. Our polytunnels are usually more or less open to the wider environment. I'd thought netting against Drosophilus suzuki might be used, but in actual fact, it seems not. It's expensive, alters airflow, and creates mold and rot problems. So there's basically nothing to stop the insects moving inside and outside the polytunnels. So if the woody hosts are grown in the polytunnels, and adults and nymphs choose to stay in the polytunnels, very warm years, they may accumulate enough degree days to develop, but we don't know. But there's nothing keeping them in there. And it was also unclear what the pathway from infested ornamental plants being imported to fruit production in polytunnels would be. So overall, the final recommendation of the PRA was no statutory action with measures I have talked about already. And I think I said the final step in the process is after the PRA has been completed, we go back and we review the scores of the risk register. We now know quite a lot about it, been able to sort some of these scores out a bit more. Scores have tumbled from about 32 down to 10, and that backs up the no statutory action in future. And if you're interested in learning more, the UK PRA on Pochazia is publicly available. A lot of the details I've been talking about in the climate temperature analysis are in the appendix, starts at the page 49 towards the end. can either find that PRA on the EPO PRA platform or on the UK Plant Health Risk Register. There's a link to it as well. And for those of you who are really interested, the UK Met Office web tool I've mentioned a few times going around. And again, that's freely available to anyone, is UK based, but it's still quite fun to have a play with. Thank you. That's me and ready for any questions.
Thank you so much, Anastasia. I admit I'm trying to think of a question at the moment because as you went, I'd go, oh, but what about this? And then you'd go a slide or two, and I went, oh, she's answered that. That's brilliant. That is a very efficient, elegant method in a data sparse environment. I think that's brilliant research as far as I'm concerned. Were there any questions from anyone else? I see we've got Tuha, we've got Alan. Hi, Connor.
Hi, Anastasia, it's Alan. Well done. That was a really good presentation. I think you said about the graph with that was the sort of clincher. So do you think that the way data is presented, I mean, there was very many graphs there, that the way that data is presented to people who, you know, make these decisions, how important is that? And, you know, should risk assessors, risk analysts really take this into account when they're, think, because some of the graphs you showed were quite innovative, you know, they're not the sort of just standard XY graphs and so on. Just a little bit about your ways of exploring data visualizations, maybe. Thank you.
Thank you, Alan. Yes, that's a very good question. I think I had a version of that graph really quite early on in the process, but I didn't show anyone until I was really sure of the data behind it. And yes, you can manipulate opinion if you're not careful with graphs. As part of being a risk analyst, you also need to be conscious of the way people will jump to conclusions with nice visualizations. And if you're not confident about your data, you don't show the visualizations, or you show them in some way that makes it clearer you're less certain about what's going on. I know that I can be, in different PRAs, I can be quite uncertain about showing a map, because maps in particular, people seem to think show the truth. And if you make a map with dodgy data, people don't read your caveats. And the same will go for a complex graph. So that maybe also answers your question in a different way, that you need to try and keep the graph simple so that people can read it without it. The message you're showing, if there's uncertainty, the graph should be simple enough that people see the uncertainty and can't miss it, if that makes sense.
Yeah, thank you. If there's nothing else, Jessica, I wonder if I could ask about climate change then.
Please do. I think that, okay, if there's no other hands up, then I'll let Alan ask a second question. No, there are not. Alan, go ahead. Anyone else, if you want to go after Alan, raise your hands.
Was there much discussion about should climate change be taken into account? And I wonder, you know, how soon, or can we estimate what climate change scenario? Well, could there be sufficient temperature for Pochazia to establish in the UK in 30 years or 50 years or 100 years, for example?
And this is one of the first PRAs where we actually explicitly mention climate change in the establishment section. So essentially, in the next 30 or 50 years, there was no climate change scenario that appeared to allow Pochazia to reliably establish. You're starting in the very warm climate change scenarios in urban heat islands, you know, some of the hottest places like London. You might get some establishment, and we also need to be aware of very warm microclimates that might allow a small population to persist. However, it took the sort of rampant fossil fuel usage scenario and looking out to 2100 before we would start to get, I suppose, significant pockets of establishment in the southeast of England, assuming what Pochazia needs is roughly correlated with where it is at the moment. And I was talking to the UK Met Office about how to get quick ideas about that. And one of the hints they gave me is if you're looking at, say, climate change of +4 degrees, that web tool I mentioned a few times going through, if you've got a threshold of 12 degrees and you're looking at climate change of 4 degrees, it is numerically okay as a first approximation to reduce your threshold temperature by about 4 degrees. So you reduce your threshold temperature down to about 8 degrees, leave the accumulated degree days the same, and that starts to give you an indication. There's no diagrams in either the PRA or this presentation because all it is an indication, but it does suggest how well or badly a pest might do under climate change. But in general, the PRA conclusion was that, you know, a PRA doesn't last 75 years. The pest is going to continue to spread, trade patterns are going to continue to change. And so in the lifetime of the PRA, there's other factors going to need to lead to a revision of the PRA before climate change is going to affect this insect's chances of establishment.
Thank you.
I've got a couple of questions, if that's okay, Anastasia, based off of climate change and
Yes.
general modelling. The first question I was wondering, is this something that tends to happen with other species in terms of the UK just having too few degree days for a pest of concern to establish and complete a life cycle? I'm just thinking, given that the UK is at a surprisingly high latitude, I mean, often we'll use degree days to constrain models to keep things out of much of Canada, and the UK is at the same latitude. Is this something that happens relatively frequently where you'll look at a pest of concern and go, oh, it's just not going to be able to live here? Or is this particularly surprising in that not only was it data sparse, but also things are unusual in that they're constrained out of the UK pretty much?
It's quite usual for the pests we model that our summers just aren't warm enough. One thing I didn't really mention is that winter isn't going to be a problem. So in general, the UK has quite warm winters and quite cool summers. We've got this really, the Gulf Stream really makes us into an oceanic. Well, obviously we vary between summer and winter, but not nearly as much. So South Korea, in the winters, it's -20, but in the summers, it's a load warmer. So essentially, for pests like Pochazia, this can be a reasonably normal pattern. Overwintering isn't a problem. Summer temperatures are. Another facet for other pests might be that other parts of the range will have 2, 3, 4 generations a year. The UK, 1 or 2, and the populations will build up less quickly before they're knocked back for the winter. So it might be able to establish, but wouldn't be able to cause economic impacts. It's something we're quite used to seeing for the UK specific modelling. our peculiarly cool summers.
Thank you. That was exactly what I was wondering. So that's really interesting to know that on the whole, the UK isn't too cold, which I wondered, it just doesn't get warm enough. Oh, and now we've got a question from Dominic. Dominic, go ahead and I'll mute myself.
Thanks, Jessica. So, Anastasia, do you think there's some of the techniques you use for this would be usable for other pests in the future? And other things you might do a bit differently if you're going to do it all again? Thanks.
So if I had better data, I wouldn't have used these techniques. But yes, for a pest with relatively few data, if we have to do it, it would be really, really interesting to keep an eye on where Pochazia spreads to, prediction testing of how far north can it get, how cool can it have its summers. So it's going to be an interesting hypothesis to test. I think we're all fairly confident that it won't establish here, but it'd be interesting to work out where its limits are. I think every risk analysis we do, every pest has its own little nuances. So not every element of what I've done for Pochazia may be appropriate for other pests, but it's definitely something we could do in future if we're faced with a similar situation, needing to give answers quickly because of real world impacts. I have to say the main thing I would do differently is try and approach it a bit more systematically. I think I mentioned it was really quite hard to come up with a linear presentation. I was casting my net extremely wide, grabbing any bit of literature I could find, hauling relevant chunks out and dumping them into appropriate spreadsheets. It was a bit of a mess. You'll be aware because you were involved in some of the decisions on action we were taking against these infested consignments. There was quite a lot of pressure on us. It had to be done quickly. There weren't any other options. And yeah, I think I would have liked to have a bit more time to sit back and do it systematically. That wasn't what I had. And I'm actually quite pleased with the way I managed, despite what felt like a scattergun jumble sale approach. I managed to gather and sort the data in a way that was useful. And I do feel reasonably confident about the outcome of this analysis, that the UK is just too cool for the pest, which I suppose is ultimately what matters most. Thank you.
Yeah, I agree. Thanks, Anastasia.
Out of curiosity, Anastasia, one last question from myself. How do you think that your results might compare to, say, you mentioned Climax, and I agree there just wasn't enough data for a full model there. What do you think would happen? Would it validate the results likely if you were to run, say, a genetic algorithm on the points that you do have, and you just assume that where you only have place names, that might be good enough? I wonder how that would correlate to your result, because I think that I think that you're right. I'm just interested to see how other methods might compare.
Yeah, and yes, I did actually consider using that. So just to take a slight step back, one of the South Korean models actually used Climax's match climates algorithm. However, they only used as their source data Zhejiang in China as the origin location, and it is from more locations in China than that. I think the main barrier is that you have got isolated, scattered records over a large amount of China. They did seem to be valid in that a lot of them were from a very detailed morphological paper on wing venation. So I trusted they were looking in a really detailed manner at the insects. But there are other species of rhicanids in Eastern Asia, and I suppose I have less confidence in some of these outlying data points in China. But I agree with you, it would be an interesting analysis to do. I just have some worried questions in the back of my head over how valid all the data location points in China are, if that makes sense.
That makes perfect sense. And as far as I'm concerned, I think that really validates the decision to try not to do it that way, because then you'd have to go through so many iterations of which ones can you leave in versus which ones really change the model consistently, and that's just not practical given the time constraints you're under.
If anyone would like to do it as a project for interest, I'd be most interested in the results.
All right. Do we have any other questions from anyone else? If we do, I'm all ears. Otherwise, we might wrap it up a little early this time. All right, well, thank you so much, Anastasia. That was a fascinating presentation, and we're really grateful for you taking the time out of your day to tell us all about this.
Thank you for inviting me.
Thank you so much. All right.
Jessica, can you just
Yes.
say a little bit about what happens next, about it being uploaded and things like that, and it'll be
Yes.
promoted so others can see it, yeah?
Of course, yes. So once I officially call it over, I will stop the recording, and then I'll send that on to our much more IT-minded folks, and we'll get this set up on YouTube. So if there's anyone within our networks who we think this would be really relevant to, but this was the wrong time for them, please do feel very free to share. This will be up on the IPRRG YouTube quite shortly.
Great, thank you.
Thanks, Alan. Good reminder. All right. Well, thank you, folks. Good morning, good afternoon, good evening, depending on where you are in the world. It's been lovely having Anastasia.
Thanks, Anastasia.